Okay, we're going to continue our discussion on linear functions. And just a question somebody asked was, how do we know if a point lies on a line? Well, quite simply, all we need to do is we need to just sub those values into the equation and to check. So remember that an equation is basically a rule where we look at how one of the variables changes. When that changes, how does the other one change? So if we look at this equation we've got down here, y equals 4 minus 2x, and we're asked, does the point minus 2, 3, or the coordinate that lie on that line? Well, of course, one way we could do it is to graph it and then like draw it and have a look. But another way is we can actually substitute in here. So we remember a coordinate is basically broken up into your x value and your y value. And so we check whether these values basically abide by this rule here that we're given for the equation. So we're simply going to go and substitute that in. So let's consider this. The right-hand side, because that's what we're talking about with the x. So when x equals minus 2, that equation simply becomes 4 minus 2 times minus 2. And that gives us now, I'm just going to set my right-hand side, equals that, which becomes now 4 plus 4, which simply equals 8. And obviously, we're told then, when x equals minus 2, this expression here is going to be 8. But we're told that y equals 3. So quite clearly, my left-hand side here equals 3. So therefore, quite clearly we can see that 3 doesn't equal 8. And therefore, that means that the point minus 2, 3 does not lie on that line. So therefore, minus 2, 3 does not lie on the line. Okay, so we can always just substitute the coordinate into the equation by doing that. All right, I'm going to continue on our discussion with it, and we're going to look at how do we graph these straight lines. So there's basically 3 methods that we're going to use for how to graph a line, and 3 different ways. The first one is that we can construct a table of values. So that's something that we looked at in the previous video. And whenever we're doing a table of values, with a linear function, we always want to do a minimum of 3 points. Now, guys, you're probably familiar that if I've got a straight line, I've got 2 points that are correct, I can connect them, and that's happy days. But we always do 3 just so that we can check that we've done the right thing there. So always do 3 if you're going to do that. The next method we can use is to actually get the x and y intercepts and then use those to graph it. The question you might be asking, well, what if there isn't one missing? So we only have an x-intercept or we only have a y-intercept. I'll get you to have a think about what's going on with those lines. I'm not going to answer that right away, but in the next video we might look at what that might mean. The third method is actually to use the y-intercept and the gradient. And we're going to look particularly at this method a bit later as well, and particularly when we look at a line and what those things mean. But for today, we're going to look at that number 2 there, and we're going to start with using the x and y intercepts to do it. So from last lesson, we found that the x-intercept, we simply made y equal 0, and then the y-intercept by letting x equal 0. And so once we've found those, we can then plot them on our Cartesian plane and connect them for a line. And so if I've got this example here, let's graph the line y equals 2x plus 1. So using that method, we want to find the x and y intercepts. So let's start by finding the y-intercept. And when do we get that? Well, when x equals 0. So when x equals 0, we're substituting, we're changing our x here in this equation in for 0. So y equals 2 times 0 plus 1. Obviously 2 times 0 is nothing, plus 1 gives us 1. And so we can say that our y-intercept for this equation is at 1. Then we're going to go and find the x-intercept. And how do we find that? Well, we make y equal to 0. So when y equals 0, from my original equation, back up the top right here, if I come down to here, I've made y now equals 0, and I get 0 equals 2x plus 1. And that gives us, if I shift across my 1, subtracting it, I get 2x equals minus 1, and then divide both sides by 2 to get x equals minus a half. Hopefully you guys are feeling good with your algebra, and you've got to end up with that. So we've got our y-intercept at 1 and our x-intercept at minus a half. Then it's simply a matter of constructing yourself a Cartesian plane I will encourage you, please make sure you're using a ruler for this. I don't have a ruler on my iPad, so I've kind of free-handed it, and you can see it's messy and gross. Whenever we're doing our Cartesian planes, make sure we're putting arrows everywhere to show that it's going on. Always label your axes, okay? So make sure you've written an X here and a Y there, just so people know what you're talking about. And it's just a matter of labeling them. So we've got our y-intercept, as we said, at 1. That's our point there. We've got our x-intercept at -1/2. Always try and make sure the scale is pretty consistent as well. And that's where a rule is going to come in handy. You can see hopefully this distance here on the x-axis is half of what it would be on my y-axis there. Once we've got those 2 points, it's just a matter of drawing in that line. Remember, in a line, unless we're given a certain limit of what we call our domain or range, it will go on forever. So that equation y equals 2x plus 1, we're putting arrows each end just to show that it goes on. And the last thing we always do when graphing on the thing is to make sure we label what that equation is. Y equals 2x plus 1. So hopefully you're good to go and sketch some lines now.